Java is an object-oriented programming language. Like C++ is also an object-oriented programming language. And what that means is that we can create our own objects and write our own classes. And this is what we're going to start learning in this chapter. When we talk about an object-oriented programming language, we are talking about a way of writing programs that models how people think about the real world. We go through the real world looking at things around us as objects. If you think about how you look at your classes, a class is an object. A professor is an object. A course is an object. A college is an object. An object is a term that basically stands for a set of variables that we are storing and a couple methods, some methods that we are storing. So an object is kind of like a programming representation of something that is a real world object or a concept. So it could be like a job description, for example. But let's think of, you as a student at college. You are storing a set of information. There is information that we need to store about you. Your name, your address, your phone number, your date of birth, your major. And then there are some methods that we can write to manipulate those variables. Like, you might be storing your GPA, and then we say, okay, calculate me your GPA. Give me a list of classes that you need to take to graduate. So there are methods that are associated with this object. So how do we use objects and classes? Well, actually, we've already been using them. So if you think about string is a class that we've been using. Scanner, file writer, file print writer, random, those are all classes that we have used. What do they have in common? Well, number one, they start with an uppercase letter. That was one difference we noted at the beginning when we started learning about string versus primitive data types. So one, they start with an uppercase letter. So when you're creating your own class, make sure that you write it with an uppercase letter. What else do these classes have? Well, they have methods. I can go to a string and say, string, give me your name. String, give me the char at location 0. I can go to a scanner and say, scanner, get me the next byte, get me the next line. I can go to print writer and say, print writer, print ln this, or close yourself. So objects have methods. What you are writing is a class. What people are creating are objects from this class. They are creating instances of this class. So whoever wrote the string class and all the methods that are in it wrote it only one time. Whoever wrote the scanner class wrote it one time. Now we as users can create many strings and many scanners. I can create a string that represents my name, a string that represents my address, and a string that represents my major. For scanner, I can create a scanner that points to system.in, and I can create a scanner that points to a file. So what we are creating are objects. So the class is written one time, and we create objects that are of this class type. We call these objects instances of the class. So you can think of a class as, something that is written only one time, and it's like the blueprint that stores, what this class should have in it, and it provides the functionality, the methods, and then what you do is create instances. So here's an example of a class called player data. And it stores two pieces of information. It's storing the name of the player and their age. Now, I can create an instance of player data that stores a dog in it. A dog that's 10, and a bird that's 9, and a cat that's 7. So I'm creating different instances. Just like I can create a string name, string address, string, something else. These classes also provide methods. So I have my information stored in the class, and then I have methods. Let's note some things here before we start writing our own classes. Here we are writing all this without main. Notice here there's no mention in main. So right at the beginning of my class, I would start saying the information that I'm storing. These are variables that I'm creating, okay? We call them the instance fields. Notice that I'm creating them and I'm putting the word private next to them. Notice here the method that I'm writing that calculates the average. It's using these variables. Notice there's a word missing from this method. Remember, we used to always write public what in our methods? Static. And this method is missing the word static. So these are some things that we're going to talk about. What does private mean? And why is it missing the word static? But before we do that, what I want to do is practice writing a little bit like we did in the player class. So here I'm going to go to Java, to NetBeans, and I'm going to create a project. Now, remember, the project always, if I look at any of my projects here, like let's say Hello World, then when I created the Hello World project, it actually created a class for me called Hello World. Now, we haven't been really paying attention to it, but it created a Hello World class, public class, Hello World, in a hello world.java file. If I want to create a student class, I will have to create a project called student. Okay, and now I created a project called student, so I have a student class inside of student.java. Now I ask myself, what information do I want to store about a student? Well, for now, we're only going to store two pieces of information: private string name and private, let's say, float tuition. Let's say these are the two things that I want to store about a student. Notice, like I said, that we are making them private. Why are we making them private? Because we do not want anyone to access this information in student without our permission. Okay? We don't want anyone to come change the name of the student or their tuition without our permission. So things that are public are things that you can call and people can use. Things that are private mean people cannot access them. We're not going to really get into private more than that in this course. We're going to see it more in the next course. But for now, know that things that you store inside your class, you should make them private so that others cannot access them without your permission. Now, I can have some methods that give me access to this information. Those are called the getter methods. They're also called the accessor methods. For example, if I want to know a student's name, I will ask to get their name. Okay, if I ask for their name, they're going to give me back their name. So they're going to return the name. Name is what type of data? It is a string. So that means my method here needs to return a string. So instead of saying public static, I will just say public. Now my method, because I want people to be able to use it, I will make it public. So field data, instance fields, those variables that we are storing, those should be private. But methods that we write should be public, unless you're writing it so people don't use it, but you're using it for your internal work, for example. So methods should be public. Instance fields should be private. Methods should be public. Methods should not be static. So we're not going to put the word static there. Now, here, if I want to know their tuition, for example, I can also say public float get tuition, and I'll return tuition. I can write other methods, like I can say public void deduct tuition. So maybe I want to say deduct from tuition, like a certain amount, let's call it deduct from tuition. And you give it an amount, let's say float amount. And what it's going to do, it's going to say the tuition is going to be decreased by that amount. So as if they paid it. So if If you ask, say, deduct $200 from their tuition, we go to the tuition and subtract from it the 200. Remember, this is the same as saying tuition equal to tuition minus amount. So you can provide as many methods as you want. Methods that give us access to the data, like I said, are called the getter methods. There are other methods that are called the setter methods. They are called the mutator methods because they mutate the object. Let's say someone changed their name. So I want to set their name. I want to change their name. So I can say set name. Well, if I want to change their name, I need to know what I need to change it to. So here I'm going to take another string as input, and I'm going to call it new name. And if you want me to change my name, what I'm going to do is I'm going to set my name, that variable that is stored here in me. I'm going to say name equal to new name. What am I doing? I am changing the name to the new name that you are giving me. Okay? And we could also do that to tuition if we wanted to. We can say set the tuition to something. If you ask me to set the tuition to something, you need to give me the new tuition. Okay, and so what I'm going to do is I'm going to set my tuition to the amount that you give me as input. So these are the setter methods. So again, kind of to recap what we did so far. Number one, when you're creating a class, you need to make sure you create your project with that name so that you get the file with that name. You need to ask yourself, what information do I need to store about this object? You know, if it's a student, their name, tuition, I might have other things like private string, their major, private float, their GPA. Okay, so a lot of information. I can store a bunch of information here. So you think, what information do I want to store? And you make them private. And this is the same as creating just regular variables. And then you ask yourself, what methods do I want to provide? What functionality do I want people to be able to call on this object? And so you start with your getter methods that give you access to information, and your setter methods that allow you to change the information that is stored. Now, note that not everything that you write, not all your variables will have a set and get method. So maybe my GPA is not going to have a set GPA. You know, GPA is something that gets calculated. I don't want a set method for it. So you don't always have to write get and set methods, but if you do, they're called the set methods and the get methods. Getters give you access to the information. The set methods give you a chance to mutate, and then you write other methods that you might need to write. Okay. So we talked about the word private. We didn't really talk about static. I will come back to static in a little bit. Okay. So I'm going to skip this slide for a second. Now, how do you create an object? Well, we've been creating objects. The way we've been doing it is we put the type of the object, which is the class name. We put a variable name, and then we say new, type again, and in parentheses, whatever it takes as input. So the way you do it is you put the class name, variable name equal new class name, and then the arguments. Now, if I wanted to create one of those objects that I have, like a student, for example, I can do this. I can say student, let's say S1 equal to new student. And right now, we'll just put empty parentheses. I can say student S2 equal to new student. Okay, so now I created two students. I want to call methods. Right now, they're empty students. They are not storing anything. Those fields are empty. I want to change the name. I want to give someone a name. So I can call the set name method. So I can go to S1 and say S1. And when I do dot, I will see the methods there. So I can say set name. So we're seeing now the methods kind of like when we had a string or math.pow. We see the methods here. So I'm going to say S1, set your name to cat. Okay. And I can also say S1, set your tuition to 100. I can then go to S2 and say, S2, you set your name to dog. And S2, you set your tuition to $90 or $900. No one pays $900, $90 in tuition anymore, right? Nothing's that cheap. So now I've used the set methods. Now what if I want to retrieve this information? Well, I can say, for example, system.out.println first student name plus, and then I can go to S1 and say, S1, get me your name. Okay. I can go to student 2 and do the same thing. Student 2 name and say S2 dot get name. Okay. So now I saved the name and the tuition, and I can retrieve them using the method. So now I know that student 1, S1 is cat and S2 is dog. Okay. And I could do the same with the tuition. So here we created objects using the new keyword, and we started calling methods on our objects. Now let's look at how we are calling these methods that we wrote. I had to, if I want to set the name of an object, I have to go to this object and say S1 dot set name. Can I just say, come here and say set name to cat like this? Java doesn't let me. And I want you to pause the video for a second and try to ask yourself and think, why doesn't it let me to just call the set name method? The set name method is up there. Well, the answer is, what object are you trying to set the name on? None. There is no object here before the set name to set the name on. It's kind of like trying to say dot length on a string. And if you don't have a string here, you can't, you can't call dot length because you don't have a string to call dot length on. So these methods that require us to have an object before, like string name, you have to come here and say name.length, do something with it, of course, print it or save it somewhere. These methods that we have to have an object to be able to call them, these methods are not static. So if you need an object to give the answer, then you're not a static method. Okay, you don't have static, and that is why we are missing the word static here. Static means it's something that's shared. Shared, anyone can call it. For example, math.pow is a shared method. When I come and say math.pow, I don't put an object before math.pow. Math is the name of the class. We're going to talk more about what this exactly means in the next Java course. But this is not an object. I don't have an object. I'm just going to the math file and saying, I want you to call the pow method in you. I don't have an object here like S1 dot, S2 dot. Anywhere you call the pow with 10, 2, you're always going to get the same answer. But if you come and you call dot length, it's going to differ what you're calling dot length on. If I call it on a string that's 7 characters long, I'm going to get 7. But if I call it on a string that's 3 characters long, I'm going to get 3. The same way here, if I say S1 dot get name, I will get cat. But if I say S2 dot get name, I will get dog. So my method here is not a shared method. You can't just go around saying, get me the name. Get me the name of what? And the what, get me the name of the what. This is the object before the dot. So these are not shared methods. They are specific to an object. You must give an object before the method name for this to work. And that is why we are missing the static keyword. Okay? If you put static, it's not going to work. And so we don't put the word static, and you cannot call them without a method. If I try calling get name, it's not going to work. It's not going to know get the name of what. So I have to have an object here. Okay, so this is the meaning of the static method. Now we talked about creating an object. How are objects stored? Now let's think about this for a second. When you're creating an object, let's actually think about primitive data types. When I'm creating some primitive data types, okay, I go to RAM, I say, I want you to create me a byte B. Okay, RAM knows that it needs to give you 1 byte in RAM. If I say, get me a float X, RAM knows that it needs to give you 4 bytes. Okay, and if you try to store something bigger than this 1 byte or 4 bytes, the code will complain and you'll get a compilation error. Now, when we're creating objects, when I just come and I say student S1, okay, what's going to happen in RAM? Because remember, we could also say byte B semicolon without the equal 10, right? We could do that. So if I say student S1, what is going to get created in RAM? Well, what gets created in RAM is just 1 byte, labeled S1. When I later say equal to new student, okay, it's going to come here, look at the code and say, okay, when I try to create a student, what do you want me to store? And here it says you want me to store a string, and a float, and a float. So I need to figure out how much space, how many bytes. So we know that for floats, we need to store 4 bytes. So I need 4 here and 4 here. So that's 8. Strings are only 1 because they're also classes. We're going to talk more about that later. But for now, we need 8 for our floats and 2 for our strings. So we need 10 bytes. So this is going to go to RAM and allocate space that is 10 bytes long. Okay. So when you're storing regular primitive data types, you only have 1 spot in RAM. Here I have 1 byte. Here I have 4 bytes. When I'm dealing with objects, you will have 1 byte to store the address of where the actual real object gets created. When I say new student, the code will go and calculate how much space is needed to create the student, and it will go allocate that space. So for a student, it might be 10 bytes. If I have like computer, I'm creating a class to represent a computer object, it might be 20 bytes. Now this 10 bytes lives somewhere in RAM. Maybe it lives at location 26 in RAM. You know, every location in RAM has an address. So what actually the variable S1 is going to store is this address 26. So this is how things are stored in RAM when we talk about objects. And so here, if I have a student, for example, and I'm storing their name, test 1, test 2, test 3, Tweety is only storing 1 byte, is only taking 1 byte in RAM. New student created the object and it went and it said, oh, I need to store the student's name and then 3 scores. Scores were floats, it's going to allocate space for floats. When you create a new object, it automatically fills things in with like zeros or empty. Numbers get the value 0, Booleans get the value false, and objects like a string would get the value null. And we're going to talk more about null later. Okay, so you need 1 space in RAM to store the address of the object, and then a big space in RAM to actually store the object itself. We talked about writing the getter and setter methods. Okay, so the getter methods are the one that give you access to the information, and the setter methods are the one that allow you to change the information that is stored. Now, one of the things that you might want to add are like other utility methods like deduct tuition, add to the tuition. So here we're adding a method called getAverage. And getAverage here is adding up the 3 numbers, the 3 test scores dividing by 3. Now, why don't we just store a variable called average? So in addition to storing name and test 1, test 2, test 3, why don't we just say private double average? Any ideas why it would not be a good idea to store the average? Well, think about it. Average depends on test 1, test 2, and test 3. If I made a mistake in entering one of the students' grades, like test grades, and the student comes and tells me it was supposed to be 98 and you put 96 for me. When I change this 96 to a 98, what do I need to do to the average? I would have to go update the average. And so data that is calculated, data that is based on other data, it is not a good idea to save it. it is better to calculate it whenever you need to. So calculated data we should not be storing, because now every time I update test 1 or test 2 or test 3, I need to make sure I go and update the average if I had it stored. So in general, you don't want to save data that is being calculated inside your classes. Okay, now when I say scanner k equal to new scanner system.in or scanner whatever equal new scanner, what I'm doing is I'm constructing an object. I'm creating a new object. So the word new is what creates a new object. These methods are called constructors. And objects can, classes can actually provide their own constructors. So what I have here is a constructor, student. I'm creating a constructor. Notice here the constructor is a method. It's a special method. It has the same name as the class. So this is the class student. My constructor is called student. It's public. It has to be public so other code can call it, because private means no one can call it. But we're going to make it public so it can be called. Notice that it's missing the static, okay? And it's also missing the return type. No void, no int, no double. It doesn't have a return type. Why? Because the constructor is going to return an object of its type. If you call the student constructor, you're going to get a student back. You call a scanner constructor, you're going to get a scanner back. You call a file constructor, you're going to get a file back. You can write as many constructors as you want with the different parameters. Remember when we talked about overloading methods? Writing methods that have the same name but different arguments. This is what we're doing. We're overloading the constructor. So I can say if I have a student that hasn't taken any test scores, I'm going to create a student with just their name. But maybe I want to provide a way to create a student that has a name and the 3 grades for their exams. Whichever method, whichever constructor you write, whatever information they give you, you need to make sure you store it. So if they give me string n as input, I need to make sure I go to the name that's stored in me and save the n in it. So name is equal to n. If they give me the test scores, I need to make sure I save the test scores there. Okay, so let's go and practice writing a couple constructors for our class. And notice what's going to happen once I start writing constructors. So here I had already created two objects, S1 and S2, using an empty constructor. This constructor is called the default constructor. So these are default constructors. They are provided automatically in Java if I don't write my own constructor. So because we didn't write our own constructor, Java lets me just use the default constructor. It's a constructor that takes nothing as input. So I'm not asking the class to save any information in it. Now let's see what's going to happen when I start writing my own constructors. So I'm going to write a couple constructors. I want to be able to create a student with just their name. So I'm going to say public student, and again, no static, no return type, n. And all I'm going to do is say name equal to n. And I could also say, for example, major equal to undecided. So I can start saving extra information in there. Since we're doing more than one thing, I'm going to put it on more than one line. So name is n, major is undecided, and let's say tuition, the basic tuition, let's say it's $3,000. Okay. And GPA, let's say we're going to start them off with a 4.0 GPA. We're nice. So this is my constructor that takes a name. Maybe I have another constructor for a student that knows their major. So they have a name, and they're going to also give me their major. Okay, and in that case, I'm going to save the name, and I'm going to save their major also. So major equal to M. And if they have a major, I'm going to say that their tuition is $4,000 instead. You can put whatever information is needed. I can have another student that takes only their name and maybe just the tuition without a major. And so you can write as many constructors as you want to make it easier for the user who is creating these objects. So kind of to give them the flexibility. So now I wrote some constructors. When I go back to main, I find red wiggly lines under the default constructors that I was using. And if I click here, it says no suitable constructor found. So if you write your own constructor, the default constructors stop working. So now I would actually have to go to S1 and say, well, let's create S3 actually. I would have to say new student, let's say rabbit, S3 as rabbit, and maybe S4 as rabbit, as let's call it lion, and lion is in computer science. Okay, so that's using the second constructor that I wrote, and let's have another student, Snake, which has a tuition of $8,000. So I'm using the different constructors, and I can call the set methods, the get methods, any methods I want on them. Now, if I really wanted to create a student with no name, which I don't think we should do, you know, imagine someone submitting an application to college without a name on it. But if I wanted to, I could. And so I can come here and say I'm going to add the empty constructor that doesn't take anything as input, and it's just not going to do anything. So you could have that constructor if you needed to have it. Okay, so those are called constructors. You write them to create objects. We talked about the default constructor that's provided by Java. If you don't write your own, Java provides you with the default constructor. Once you start writing your own constructor, the default constructor is no longer valid. Okay. So for today's classwork, what I want you to do is I want you to create a project called employee so that you get a class called employee. And I want this employee to store two pieces of information, their name and their salary. I want you to write the getters and set methods. So the get name, the get salary, set name, set salary. After you do that in main, you're going to create two employees, kind of like what I did in my NetBeans. I wrote my instance fields. I wrote my set and get methods. Okay, and then in main, I created two students. You're going to create two employees. Now, how are you going to know the employees' names and salaries? Well, you're going to ask the user. So you're going to create two employees. Here, I didn't ask you to write any constructors. You're going to do that in the next assignment. So you're going to use the default constructors provided by Java. After you create your employees, you're going to ask the user for the name and salary of each employee, and you're going to use the set methods to update them. So set name to change the name, and set salary to change the salary of each one. And then you're going to print the information in the users using the get methods. Make sure that when you print the information, you show it with 2 digits after the decimal. And then submit your work on, test your work on HackerRank and submit it on Blackboard.